There are 31 Class 91 locomotives, and along with the Mark IV coaches they form the IC225 train sets. These trains operate on the East Coast Main Line between London and Scotland. The locomotives were built with a mix of old and new technologies. They were one of the first sets of locomotives to have microprocessor control. This mix of technologies has brought its own problems, which has then led to reliability performance levels that we have now.
The story of the Class 91 is typical of much which happened on the railway. BRD's Treasury rules, it was about building things down to a price rather than up to a specification.
We want the passenger, when they get on our train, never to think about that there's a problem with reliability. We want them to get on our train and just assume it is going to arrive. So although today around 90% of our trains arrive within 10 minutes, that is not acceptable to today's passenger. They want a greater reliability. So the need through this partnership to further develop the reliability of the locomotives is absolutely essential in delivering what the passenger wants.
Hsbc Rail and its partners are investing over £40 million in improving the Class 91 rolling stock. The programme will take around 3 or 4 years and will be investing in things like spares, maintenance, but particularly some key components will be re-engineered to improve long-term reliability.
Following some preliminary work in 1998, the project was launched in January 1999, and the programme will run until March 2003, when the last locomotive through the programme will re-enter service. As well as the 2 lead organisations, there are 4 other companies involved in the project: Alstom, AEA Technology Rail, Adtrans and Interfleet Technology. Between them, these companies have people working on the project who have been involved in the trains for over 10 years. With overall control through the project operations group, specific tasks are carried out by the 4 key suppliers involved in the project. Technical support and improvements at a depot level have been provided by Alstom staff working full-time with the GNER maintenance teams. Pantograph improvements have been the focus for AEA Technology Rail, while Adtrans have concentrated on bogie and transmission systems. The 4th supplier, Interfleet Technology, have contributed to a number of projects, including compressors, parking brakes and field contactors. 8 of the top 10 Class 91 impact minute causes were related to the locomotive electrical systems. Work already undertaken to date on the programme has focused on tackling these problems. One example is the work carried out on the field contactors. These devices cut power to the motor field circuit when the motors are being stopped. Problems included the contactor tips welding together and the control interlocks failing to operate. Modifications have been developed to make them more robust, both electrically and mechanically. To date, benefits have been achieved, and we have reduced impact minutes associated with field contactors by several hundred minutes per year. Work has also been carried out on the traction motors to optimise the maintenance regime. The motors suffer from poor reliability and fail due to flashovers. A new maintenance regime has changed the way the motors are overhauled and set up to reduce the risk of flashovers occurring. This has had an additional benefit in that reduced numbers of flashovers improve the availability of the fleet.
We're involved with the pantograph, the current collection device on the roof of the locomotive, and there are some improvements that we've now analysed and can put into effect. Other areas that we're looking at are the relays and contactors, which actually cause the traction packages to cut in and out. And there are 34 neutral sections between King's Cross and Edinburgh where this locomotive basically switches itself on and off.
In 1998, relays were the 3rd biggest cause of impact minutes on the locomotive. These devices are old technology and are difficult to maintain. Failures of individual relays can cause the failure of the whole locomotive. Rather than re-engineering the existing devices, the team will be involved in replacing the relays with new sealed technology. A reconfiguration of the circuits and fitting sealed units will eliminate single point failures. This will result in a saving of over 1,000 impact minutes per year. Air management work has been carried out to improve the equipment bay environment. High temperatures in the